Alright, the best way to complete a service calculation is to read the whole thing. So we're asked to complete a service calculation for a single dwelling which has a floor area of 100 meters squared on the main floor, 100 meters squared on the top floor, and 100 meters squared in the basement. The electrical load consists of a 6,000 watt electric range, a 3,500 watt dryer, 2,100 watt sauna heater, 9,500 watt baseboard heaters with individual thermostatic control, a 2,500 watt air conditioner, and a 3,900 watt water heater. Now, obviously this water heater will be an electric water heater. Remember, that one will be at 25%. We'll note the electric space heating and air conditioning loads are interlocked and can't be used at the same time. So we'll calculate the total wattage and total amperage, making sure we show all calculations. Alright, so where do we begin? So we've got a 3-level house here. So here's your basement, your main floor, your upper floor, and of course your roof. And they're all at 100 meters squared. So 100 meters squared for the top, 100 for the middle, and we have 100 meters squared in the basement, but we know using Rule 8110, determination of areas, that we're only going to take 75% of that, which would be 75 meters squared. So if you add that up, our total inside dimension floor area, and that's another thing I should mention, this is the inside dimension, is 275 meters squared. Now that we got that, we can carry on trying to figure out our basic load. So we'll take 275 meters squared and subtract it from 90 meters squared, and that will give us our first 5,000 watts for our basic load. And what we're left with is 185 meters squared. Subtract 90 meters squared, and we'll add 1,000 watts to our calculation. And we have 95 meters squared left. Subtract 90, another 1,000, 5 meters squared left. That's that portion thereof of 90. So it would count towards another 1,000. So you can see our basic load is 8,000 watts. Okay, next step. The electric load consists of 6,000 watt electric range. Well, we can add the whole 6,000 right here because we know that it's 6,000 watts for an electric range all the way up to 12,000 watts. And if it's over 12,000 watts, we would add the 6,000 plus any amount over 12,000 at 40%. So we've got that covered. Now we've got our dryer. And our dryer falls into those additional loads. And so if we look at a dryer and we say the dryer is 3,500 watts, well, we're only going to take 25% of that dryer. So 3,500 times 0.25 is 875 watts. So we could add that to our calculation. Now, we have a sauna heater and we have baseboard heaters. So we need to put them together because they both have those individual thermostatic controls. So let's do that over here. So you have 9,500 watts plus 2,100 watts. And that's going to give you 11,600 watts. Now, if we look at that rule closely in 62116, it says take the first 10,000 watts at 100%. So this will be our heat. And it says take the remaining, that 1,600, and we take that at 75%. So 1,600 times 0.75 is 1,200 watts. So we can add that over here. Now, next we have a 2,500 watt air conditioner. Well, we know the heat's already larger than that 2,500 watt air conditioner. And in this case, it's interlocked, so they cannot be on the same time. So we're going to take the larger of the two. So in essence, we don't need to add the air conditioner to the load service calculation. And the last thing we have is a 3,900 watt electric water heater. Now that falls under additional loads. So 3,900 watts. We're only going to take a 25% demand factor. So 3,900 times 0.25 is 975 watts. So we could add that in. And again, that's going to be our electric hot water. And now we get to add them. Alright, so if we add the total, we're going to get 27,050 watts. Now, before we go on, this electric hot water heater, that is the kind that sits on the floor, and it's a big cylinder type. That's the one we're going to take at 25%, because I did say, actually I just said water heater, electric water heater. There's a difference. The tankless kind, if I said the word electric tankless water heater, that would be at 100%. So I just want to clarify to make sure that that water heater is this one here, in which case take 25% of 3,900, which would give us 975, okay? So the last thing we need to do is, now we've found our total for our power, is we need to put in the formula to find current. So 27,050 watts divided by 240 volts, and our total current is going to equal 112.7 amps. And that's the end of our service calculation.